When working with variables, we need to be able to identify what type of variable it is in order to know what kind of statistical operations we can do with them. So first we're going to divide our variables into two types, which is categorical, which tend to be names and labels, versus quantitative, which is numbers. And by numbers, we mean numbers that you can do a computation with. So if I talk about social security number, that's categorical because it is a label. It is not something that I can do a computation with. I can't take a list of social security numbers and find the average social security number. Quantitative numbers would be something where you could find a mean or find a median, so various different things. And we'll see all the different things we can do with those values in Chapter 3. So, categorical variables can be broken down into nominal and ordinal. And nominal, again, is names and labels. Whereas ordinal adds in the fact that there can be an order. Now, one thing you want to keep in mind, if I look at some nominal variables, or if I look at the nominal variable colors of cars, so you could have a blue car, or a red car, or a white car, or a green car, and so on. There's no particular order those colors need to be in based on the colors themselves. So there's no order to that list. You could put them in alphabetical order, but that doesn't have anything to do with the values of the colors themselves. So that's at the nominal level. Ordinal would be where there is some particular order to your values. So if we were talking about t-shirt size, we have small, medium, large, and so on. And so there's an order to those values. Even though they're not quantitative, we couldn't do any math with those values. So those are all categorical, nominal and ordinal. Now quantitative, we have interval and ratio. Interval we don't use a whole lot. This would be temperature and time when we're talking about what year it is. So if we were looking at the birth year of a list of people, we have 1987, 2003, 2001, 1994, and so on. This would be at the interval level because there's no starting point. So we can find differences between 2 years, or the difference between 2 years, but we can't say that someone's birth year is twice as much as another person's birth year. That doesn't really make any sense. With temperature, even though there's zero, there is a zero starting point. Well, I shouldn't say a zero starting point, but a zero value in Fahrenheit and Celsius. It's not a starting point. So it doesn't indicate a total lack of heat. So it's just a value on the scale that was decided somewhat arbitrarily by the people who made up the scale. Now with the Kelvin scale, 0 does mean a total lack of heat. So that would not be in the interval. So temperature is only for Fahrenheit and Celsius, which is what we most commonly use. Ratio is where you can talk about the ratio between two values, and this is most common. So with our ratio level, we could be talking about heights. We could be talking about number of eggs in a recipe. So various different things. All of these things we could say one person could be twice as tall as another. This basket has twice as many eggs as another. So we can talk about ratios. Now, quantitative variables can also be categorized as discrete or continuous. So discrete values are values that can be counted, versus continuous values which are measured. When we're talking about discrete variables, we're answering the question, how many? And with continuous, we're talking about how much of something there is. With discrete, we usually use the word number, versus continuous, where we say the amount. So I often hear people say the amount of people at a party or something like that. And you never want to say the amount of people, because you're not saying how much people are at the event. You're saying how many people are there. So you would say the number of people, because you can count the number of people. You don't measure the amount of people that are at a particular event. So that's the difference between discrete and continuous. So discrete we can count, and continuous we measure. So with continuous, you can always find another value between any two different values. So if we're talking about height, you could have somebody who is, 67 inches and another person who is 68 inches, but there's a value in between there, right? So there's many values in between there. As opposed to if we're talking about how many eggs in a basket, there's 2 or 3, there's no in between for that. So those are whole quantities that we're talking about. So that's how variables work in statistics.